Welcome to Hydrology Hub. In previous lecture, we defined SCS unit hydrograph and lag concepts. In this lecture, we are using another transform method and learn how to compute the Clark unit hydrograph parameters, that is time of concentration Tc and storage coefficient R. These two parameters control runoff timing and attenuation and directly influence peak discharge and hydrograph shape. So first of all, what is the Clark unit hydrograph? Clark unit hydrograph combines translation of runoff using time of concentration Tc and attenuation of runoff using storage coefficient R. In simple terms, Tc controls how fast water reaches the outlet and R controls how much the hydrograph spreads and smooths. Accurate estimation of both is essential for reliable flood modeling. Now we'll talk about computing time of concentration Tc. We will compute Tc using Kirpich equation, which is widely used for small to medium natural watershed. The Kirpich formula says time of concentration Tc is equal to 0.0195 into L to the power 0.77 into S to the power minus 0.385, where Tc is equal to time of concentration in minutes and L is main stream length in meter. S is mean slope of the main stream in meter per meter. Now, I'll tell you how to compute TC and R in HEC-HMS. First of all, we will open the HEC-HMS. Already we have set up the model in the previous lectures. So, we'll open the same HEC-HMS model. So, in our HEC-HMS model, setup basin is divided into two sub-basins. Now we will select Clark unit hydrograph under transform in each sub-basin. Therefore, first of all, we'll select sub-basin 2, click on transform and select Clark unit hydrograph. Similarly, select sub-basin 4, click on transform and select Clark unit hydrograph. Now, deselect the individual sub-basin by clicking Add Basin Model Example 1. Now select Parameter, click on Characteristics and then select Subbasins. Here it gives longest flow path length in kilometer and longest flow path slope in meter per meter for each subbasin. Now close the window. These values we will be using to compute time of concentration Tc and storage coefficient R or Clark unit hydrograph method. Now select time of concentration column. Now click on parameters, then transform and then click Clark unit hydrograph. So here you will see another window is open. It says the Clark unit hydrograph. Okay. So in this window, you can see there are columns of the Clark method and the time of concentration and storage coefficient. So the time of concentration and storage coefficient columns are blank. Now select time of concentration column. HEC-HMS provides an inbuilt calculator which avoids manual mistakes and ensures consistent units. So select calculator, click states in the calculator. It gives a list of all the basin and reach variables already computed by HEC-HMS from DAM. Now we will compute time of concentration Tc as given by Kirpich equation using the calculator. In the calculator tools, we will write the Kirpich equation. So now enter 0.0195 into POW. So here select the power options. So this is POW, base, Here base is longest flow path length, which is in kilometer. Double click here. It is in kilometer, therefore multiply it with 1000 for converting it in meter. Now power is 0.77. So we will write here 0.77. Now again multiply it with power, and here the base is longest flow path slope and power is minus 0.385. Now this value gives the time of concentration in minutes. So convert output in minutes to hours, as your basin model uses hourly time step. Therefore divide it by 60 for converting it in hours. Now click on calculate, select the formula and copy so that the same may be used while computing the storage coefficient. You can save this selected formula somewhere in the Word file. Now in the Clark Unit Hydrograph window, the computed time of concentration values are filled up. Now here click apply to apply these values. Now compute storage coefficient. Once the time of concentration is estimated, the storage coefficient will be estimated using the Tc and R relationship from the nearby watersheds. Here suppose the relationship is R upon Tc plus R is equal to 0.65 or R is equal to 13 by 7 into Tc. Now select field storage coefficient in the calculator and enter the storage equation, that is R is equal to 13 by 7 into Tc. So entering 13 by 7 into and paste the time of concentration equation here, which we have already copied. Now click calculate. It has computed the storage coefficient and it is now filled in the storage coefficient column in Clark Unit Hydrograph window. Now click apply in this window to apply the computed values. This provides an initial estimate of R, which can be later be refined during calibration to match the observed hydrograph. Now click Subbasin 2, select Transform in the Edit window and see the time of concentration and storage values calculated using the calculator are filled up here. These two values now define how rainfall axis transforms into a runoff hydrograph. Now let us discuss about the effect of Tc and R on hydrograph. Higher the Tc means the slower response and delayed peak. Higher the value of R means more attenuation and flatter hydrograph. Lower Tc and R means sharp and early peak discharge. Understanding sensitivity helps in flood peak management studies. Now the common mistakes to avoid: mixing minutes and hours, using unrealistic slope values, ignoring watershed scales limit of Kirpich equation, assigning identical Tc and R for all subbasins without analysis. Now here key takeaways are: Clark Unit Hydrograph requires two parameters, Tc and R. Kirpich equation is efficient for Tc estimation. R is equal to 13 by 7 Tc is a practical initial assumption. Calibration improves the accuracy. So in this lecture, we learned how to compute time of concentration using Kirpich equation, estimate storage coefficient R, assigning Clark parameters in HEC-HMS. If you found this helpful, like, subscribe to Hydrology Hub, share your queries in the comments. Keep learning, keep modeling. This is Hydrology Hub.